Okay, this is Michelle Cullen, and we're still with Week 3 Sky and Seasons Part 2. We're going to move on to how the Earth rotates. So we've got the apparent rotation of the Earth. We know that it spins every day, and that spinning makes the stars appear to move in the sky, and the sun appears to move in the sky during the day. So I'm going to have a video that's going to show that, show the rotating Earth. Okay, here is, if I can get it to play, here is a video from the Kurdistan Planetarium showing the Earth spinning in space. I'm sure this is something you know, that the sun appears to rise in the east and set in the west. Here it goes across the United States, goes across Asia, and when we look at it from the top, it's appearing to move in this direction, which is counterclockwise. But when we look at it from the bottom, it's rotating clockwise. It's really the same rotation. It just depends on where you look at it from your perspective. So if you're looking at it from the side or from the bottom, it's spinning the same way. It's just a matter of where you are, your viewing perspective. It's this rotation of the Earth that causes the apparent rotation of the stars in the sky over time. You would look north here, you would see the stars rise in the east and set in the west. And the circumpolar stars are the ones that you can be seen all the time rotating around this bright star here, Polaris, which is not the brightest star in the sky, but you found from lab this week that it's easily recognizable. Not only do we have the planet spinning around once on its axis every 24 hours, but we have another type of rotation. We have the annual motion of the sun, of the planet Earth going around the sun in 365 days. So this annual motion of the Earth causes different constellations and different stars to be able to be seen in relationship to where we are in the night sky. So this is kind of why we've divided up our constellation of the week into 12 different months, because we're going to say that the stars that are located over here in January, if we were here in January, this is the sun, we're looking away from the sun, this is nighttime, we'll be able to see Cancer and all the different stars that are around this constellation in the giant celestial sphere of the different stars that are visible from the planet Earth. So as we were traveling around into the summer, into August and September now, we were able to see different stars. We'd be able to see Pisces and the different stars that were located around that. So the annual motion is important. The third type of rotation that we have is that we are located in our Milky Way galaxy. So as we are rotating around the sun, going around in our little solar system, all of the planets rotating around our sun, the entire galaxy of the Milky Way is swirling, and we're able to rotate around it in very, very long distances, longer than we would ever be visible. But as we go around the sun, we're going to be able to see the center of the galaxy, and then later in the year when we're over on this side of the sun, we'll be looking away from the center of the Milky Way. So what does this look like? Well, it looks like the Milky Way. This is actually the plane of the galaxy, and we're tilted a little bit. The plane of the galaxy is not exactly equal to the plane of our solar system. It got skewed a little bit, so that's why this is not directly on the ecliptic or on the path of the other planets in our skies. It's a little different. So it's kind of cool. We move lots of different ways in space.